So I finally, make it back to the, lecture like in class. Okay, so yeah, the first project is actually due this week, right? Today? Okay, yeah. So to be honest, the first project will use MLP, which we are teaching right now. So to be honest, we are a little bit behind the schedule. The reason is, because of my trip to Vienna and I remember we have a holiday, right? Yeah, so those contribute to a little bit behind the schedule, but the MLP is relatively easy, so I think it should be okay. But I'm going to post the second project before next week, okay? So just want you to be aware, okay? If you want to get started early, okay, please remember to download and start working on the second project, which is, it will be on CNN, okay, before next week, okay, from the EE class, okay. So anyway, so that's, let's try to get this MLP stuff over with, okay. So at the end of last lecture, we talked about using Keras to create the model that recognize the fashion MNIST data set, right? To classify the data set, and to be exact, we are talking about the sequential API, okay? So we can, obviously also use the sequential API to create the model for the regression task, okay? I already explained what the regression task is, right? So basically you need to predict or you need to regress a number, okay, from this model. So one of the good example that use the regression MLP is a California housing problem. Okay, in this data set, you are given a number of features, okay, such as locations or the price of the neighbors, okay, etc. Okay, and then you need to predict the cost of a house. Okay, so similarly we can load the data set from the scikit-learn, okay, and then we split the data set for the test, training and test into training set and test set, and then you just import the standard scalar, which is used for the data preprocessing, and that's it's pretty much about it. Okay, this part is about data retrieval and data preprocessing. So I think that those are pretty standard. We split the data, as I said, into training set, test set, and the validation set, and we use the standard scalar to scale the different features, so that each feature will have the similar inference to your prediction. Okay, so and then here, okay, we can use the sequential model to create, sequential API to create a regression model, okay? And compared with the facial MNIST model. This one is, obviously a lot easier. Okay, you can see we only have one hidden layer. Okay, and then this is actually the second layer is actually the output layer. Okay, the output layer only has one neuron because we are only predicting one number. Okay, which is the price of the house. Okay, and because the price of the house, is a positive, right? And it doesn't have a limit, especially if you consider like the house cost. Or like in the current market, the house is so expensive, right? So we don't use any activation function there. Okay, remember like we talk about like a number of consideration when you create a regression model. Okay, if you're of course, like since the house price is positive, you can also consider using the ReLU activation for your output layer. Okay, but of course, if you don't want to use that should be fine. Okay, and you can see this is much easier model, as I said, than the facial MNIST one. And then we compile the model. Okay. We use mean square error, okay, as a loss function, okay, SGD, and then we train the model, okay, pretty much for 20 epoch, and that's it, okay. And then with the trained model, you can do you can evaluate it, and you can even use the trained model to do certain predictions. That's pretty straightforward, okay. So pretty much, okay, we show you what happens. I show you like how to use a sequential API to create a classification model and a regression model. Okay. But the sequential API is good only for what we call like a simple model, in the sense that the model is only like a feed forward. Okay, you only have one data one path for the data processing. Okay, in the model. Okay, if that's the case, sequential API work pretty well, okay? But if you want to create a more complicated model, for example, okay, sometimes you want, you may have like the data that need to go through the model with more than one path, okay? Or sometimes you may want your model to be able to deal with more than one input. Okay, or even more than one output. You may wonder like in what situation do we need like the model that deals with more than one input? Here, when I say more than one input, I'm not saying like more than one feature. Of course, like sequential data is able to do that. Okay, I'm talking about like you have two sets of inputs. One set goes through one path, the other set of input that goes through the other path. Okay, and for this type of like a more complicated model, okay, the Keras provide the functional API to deal with that. Okay, so what is functional API? Okay, it's again, the best that we just show how it is used to create a model by means of an example. Okay, here we are trying to introduce a model. Okay, which is called wide and deep. Okay, wide and deep neural network model. Okay, so this model actually was created by Dr. Heng Zhizhen. Okay, I mean, just by looking this name, I mean, you feel like a very close to you guys, right? Because yes, this guy is from Taiwan, okay? And I believe he got his PhD from Carnegie Mellon, and he's now working for Google, if I remember correctly. Okay, so this guy made some very important contribution to the recent advancement of the deep learning. Okay, I mean, one of the important concepts he proposed is this wide and deep. Of course, this wide and deep concept later on, okay, becomes like maybe like a sparking, source of the ResNet, okay, residual network, okay, which we will talk about, okay, in the next chapter. I mean, if you know ResNet, okay, you will know like how important that concept is, okay. So basically, what is this wide and deep neural network is? Let me show you, the figure, which is much easier to understand for you, okay. So you have this input, and this input, without looking this path, without looking this second path, okay, it looks just like a regular MLP. Okay, this input goes through the hidden layer 1, hidden layer 2, okay, and then go to the output layer, right? But, okay, here's the interesting part. Okay, this input actually has a second path. It goes, directly to here. So you can see that this data, this input data, actually has two paths. One goes through here, okay, one goes through here. We call this path deep. We call this path wide, okay? Actually, okay, later on when you learn the residual network or ResNet, this path is sometimes also called skip connection because it skips several layers, right? It skips several layers. So what is the interesting part of this network? Okay, when Dr. Zheng proposed this idea, he said, okay, that some features are better to be processed by multiple layers, multiple hidden layers. But some features, especially the simple ones, are better to be extracted directly from the input layer. Okay, so you can consider this path is good for the more hidden feature, the more complicated feature that need certain computation to extract it. And this path, this wide path, is good for those features which are relatively easy, okay? And the most important thing is for those simple feature, okay, if you try to have those simple features to go through the hidden layers, sometimes you may break because of the extra, additional computations introduced in the extra layers. I mean, it may break those simple feature. It may hurt basically like damage those simple features. So that's why the Dr. Zheng proposed this idea. But later on, as I said, okay, in a residual network, this idea, okay, is no longer considered that simple. Okay, we call that skip connection, and the whole idea becomes what we call residual learning. Okay, but so this is kind of like before ResNet was introduced. Okay, an interesting idea, a very interesting idea. Okay, so but obviously, okay, if you try to use a sequential API to create this model, you will encounter issues, right? Because sequential API doesn't do the model with multiple paths, right? It just doesn't work. Okay, so what do we do? Okay, so we can use the what we call functional API. Okay, so let's assume this model is for the California housing problem, the same problem that we just mentioned. Okay, that is a regression model, right? So here, okay, you can see this is how the functional API work. Okay, so input equal to this one. Keras.layer.input shape. Okay, also we specify the shape of the input. Okay, and then the interesting part starts from the second line. Of course, I mean before that you can see that we didn't create a model object first, right? We didn't create a model object first. And we didn't wrap this thing into the model constructor either. Okay, so we first create this layer, and then the interesting part is the second line. Okay, you see hidden one equal to Keras.layers.dense 30. Okay, well, so it contains 30 neurons, and we use ReLU activation. So far so good, but the most important thing is here. Input. You can see that we sort of tell this hidden one, okay, is going to use the input, this input layer as its previous layer. And we actually pass this layer as an argument, okay, at the end of this layer, so that we indicate that, okay, this input layer is the previous layer of the hidden one. Okay, and then, okay, for the hidden two, okay, for the next hidden layer, similar things. Okay, we create a layer with 30 neuron activation, ReLU, and then we know the previous layer of this hidden two is hidden one, right? So we put hidden one as the argument here. So we sort of treat this whole layer construction statement like a function, because, well, we provide the argument at the end, right? So this is exactly what I was mentioned. Like we treat, this is why this approach is called like a functional API. Okay. And then, okay, the next layer is concatenation layer, right? Concat. So in the concat, this is where we need to, have these two paths joined together, right? So what do we do? Okay, concat equal to Keras.layers.concatenate. Okay, so we have a specific, function that we allowed us to create a concatenation layer. Okay, what concatenation layer does is basically just put everything together, okay, into just one layer. Put them together. Okay, that's concatenation. So, but here you can see its previous layer contains hidden two and the input. Okay, so we can put we can have like a multiple inputs, multiple layers to be the previous layer in the functional API, okay, which was not possible in the sequential API. Okay, and the rest of the thing is pretty much straightforward, right? So we just the output is just Keras.layers.dense. Okay, we have one neuron because this is a regression task, and the previous layer is concatenation. Okay, and then now is a time to create a model. Okay, so if you are using the functional API, after you specify the relationship between each layers, okay? Then here, okay, you create a model, okay? Model equal to keras.model, okay? But here, okay, you need to specify which is your input layer, which is your output layer, okay? If you don't have this line, you don't have a model in a functional API, even after you specify the relationship between different layers, okay? So I think I already explained like this stuff, so I will just go over them very quickly, okay? And okay, so you can see that. Come back to here, okay? So when I say, okay, we need to specify the input and the output when we create a model, okay? It actually implies, okay, it allows us to have like more than one input or more than one output in our model. Okay, let me show you, okay? For example, okay, let me show you the figure. Okay, maybe in our features, after we've processed the features, okay, we know certain features are simple features. As I said, those should go through the wide path. And the other features are, hidden features, more complicated ones that need to go through like a deep path. So you can break the feature into two sets. One is input A, one is input B. Okay? These two different set of features do not necessarily need to be disjoint. Some features may appear in both input A and input B. That's fine. That's totally fine. Okay? The more important thing, this is just an example. I just want you to tell you, okay, the functional API is able to deal with like multiple inputs, and in sometimes when you want to create like a model with like multiple inputs, this is like one of the reasons. And here, okay, we do need to make sure our data set, okay, to be processed so that we have input A and input B in place, okay, and here, okay, so this is like the Keras API, functional API to create this model. We have the input A layer, okay, which is actually wide input. That does not go through like hidden layers. And we have input B, okay, we call it deep input, okay. And we have two hidden layers, and this first hidden layer use input B as like its previous layer. The second hidden layer use the hidden one, the previous hidden layer as its input, okay. And then, okay, again we concatenate, okay, the input A and the result hidden 2, okay, by using the concatenation layer, and then the other part are the same. Of course, like you also need to make sure that your data, okay, to be processed so that it has multiple inputs, okay. So you can see here, okay, we create like a training set for the input A and the input B, okay, not only for the training set but for the validation set, test set, okay, we need to create all this. And if you look at this code carefully, you will see the thing I just mentioned, okay. Actually, the features in the input A and the input B are not disjoint. Okay, there are some features that actually appear on both input A and the input B. And then, we can do the model fit, okay. we need to compile a model first here. We use MSE for training, for loss, and we use the SGD, and then we use the model.fit, okay? But here, okay, we need to make sure, okay, to provide the data set in the right format, okay? And the same thing, okay, the validation set also need to have input, I mean both A and B, okay? But because we only have one output, so we only have one validation, okay? The output is, or put it in another way, the ground truth is the same, okay? We only have one ground truth. So the other part is pretty much similar to what we have seen previously. Okay, so this is for the multiple input example, okay? That obviously, I mean, if you don't use functional API, you cannot do it with the sequential API, okay? And we could possibly have like a multiple outputs as well. I mean, for one model to have multiple outputs. What scenario do we need to do that? Okay, there are two possible cases. The first case is that, okay, sometimes, okay, you want one model to do two jobs. I mean, normally you will create one model for one task, right? This is the simplest approach. One model for one specific task. Okay, but if you want to complete two jobs, okay, together, okay, and you create two models, obviously, like, and it happened, you know, if these two models happen to use the same input, okay, and then, you know, running the two models obviously is going to take more time, right? It's going to, you know, be slower than one model, right? Okay, so if you are able to use just one model to complete like two tasks simultaneously, wouldn't that be nice? Because it will save you some time as well, right? So one example here, okay, is like, okay, for example, if you want to, you know, use like, you know, recognize the face. Okay, so for example, I mean, the input is a person's face, and you want to classify the person's facial expression. So this is a classification task. Okay, if this person is smiling, he's sad, or well, he's crying. You know, we want to, I mean, be able to classify, that face into several different classes. But at the same time, okay, we want to identify if this person is wearing glasses, okay, and which obviously is a binary classification task, right? And both tasks obviously, will use the same input, okay, the face, okay, as the input for the model, right? You could create, like as I said, you could create two models, one for each task, but running this is going to take a longer time. So as I said, you could use you can just create one model and have multiple outputs, okay? And so this is obviously one reason, okay, for a model to have multiple outputs. The other example is that, okay, sometimes, okay, we could use like the additional output as a regularization technique. Okay, remember regularization, what regularization, is? Okay, we talked about the L1, L2, right? Previously, right? So basically, the regularization idea is to put certain constraint to the freedom of the model, right? Because sometimes the model is too, what should I say? It has too much freedom, so it overfits, right? The model overfits, and the regularization idea is just to constrain the model so that it is not as free as indicated by the number of parameters. So here, okay, if you have more than one output, okay, you can use one of the output, okay, as you can confine that output. Okay, put certain constraint to that output, and then